guys watching. This is actually a live version of the lecture because we have two of my star and favorite students are watching this live and will be participating and asking questions. So can I get a holler at me, yo? There we go. For our tutorial, feel free to tweet hashtag get excited throughout the experience because nobody knows how to get excited like me when I'm teaching dimensional analysis. So, okay, let's talk about some rules. Hashtag these are rules. The first rule when you're doing dimensional analysis is you label a given. I don't think I even told you what dimensional analysis is. So let's just calm down for a second and talk about that. Dimensional analysis is the method of taking one unit, like something in meters, and converting it to a different unit, like millimeters. That's all. That's what it is. Just conversion. It's just a long way of saying conversions. So we're going to learn about conversions. Get excited. Hashtag get excited. Okay, first thing you do when you're doing problems is you label your given. Okay, that's number one. Label your given. What is a given? It's just the number that you were given in the problem. So in this problem, I am given 1,600 meters, so I just label it G. That's my given. The second thing you do is label your looking for, which is a really trendy, shortened way of saying, what are you looking for in your problem? And third thing we do is we find the conversion, and what are we converting between? We're converting between meters and millimeters. So look on your handy-dandy chart that is on the top of your notes, and you should see a conversion to take you from meters to millimeters. So this is your conversion factor. It takes us from meters to millimeters, okay? Now, before we move on, I'm just going to tell you something kind of interesting about conversion factors. Conversion factors can be set up as a fraction, which is kind of cool, and they can be set up as a fraction two ways. You can set them up as a fraction where they look like that, or you can set them up as a fraction to where they look like this. Now you're probably thinking, why in the world would I want to set up a conversion factor like a fraction? Well, that's a great question, and we're going to talk about why you're going to need that. But for now, I'm going to hold you in suspense. Everyone, stay calm. Hashtag stay calm, and I will tell you why you'll need to know this in a few brief moments. We found our conversion. Check, check, check. Fourth is to set up a T-chart. What is a T-chart? Well, it looks like a really long T. The very top left corner of the T, you always place your given. So 1,600 meters goes here. If I only have a single unit in my given, then underneath here is always going to be 1. Unless I have something like meters per second, in which case second would go on the bottom. But if it's just 1 unit, you always put 1 on the bottom. Now, in this little bracket, this little square here is where you put your fractions that I showed you earlier. You might want to ask yourself, which way do I want the fraction to go? If you're wanting millimeters, then that means you want to cancel out of meters, okay? And the only way you can cancel in math is to put something on the bottom that has the same unit. So if I was going to take my conversion factor, I want the 1 meter to be on the bottom and the 1,000 millimeters to be on top, because guess what I can do now with my meter units? I can cancel them out. They are no longer needed. You are the weakest link. Goodbye. What unit am I left with now? Millimeters! So that's what I needed in, right? So we're good to go. So now that we've set up the T-chart, we multiply and we divide. You multiply all the top, all the way across. It's 1,600,000, which is 1,600,000, and don't forget to put your unit there, millimeters. And then you multiply all the way across the bottom, which is just 1, because we canceled out the end. And then the step 6 is just to divide these two numbers, which is just the top number. And hashtag yeah, because you're done. Okay, so you're walking down the street and someone else comes up to you and says, you look really smart. Can you tell me how many seconds are in 4.3 years? And they're trying to like stump you, but they didn't know that you had me for chemistry and you know how to do this and it's really easy. So this is what you're going to do. This is what you would tell them. You'd be like, well, first off, I'm going to label my given. That's the number you're given, so we label it G. And then we label our looking for, which is seconds. That's what we want to go to, okay? Find a conversion factor that goes between the two. The first one I can think of is, okay, so we're starting with years. So 1 year is equal to how many? 2 days. That's shorter. So 365 days. Okay, 1 day is equal to 24 hours. 1 hour is equal to 60 minutes. And then 1 minute is equal to 60 seconds. So we actually have to use 4 different conversion factors to get us to our thing. So when you set up the T-chart, make this one extra long. The T-chart, we put the given on top. Always put your given on top and include your units. If you don't include the units, I might yell at you really loudly. In a nice way. I'll yell at you in a nice way. So 1 goes on the bottom. Okay, so if I have 4 conversion factors, that means I need to have 4 boxes for my conversion factors to go in. So here's the first box, here's the second box, here's the third box, here's the fourth box. So make 4 boxes. Now which conversion factor are you going to want to use first? Well, you have years here, so you have to use a conversion factor that has years in it, so you can cancel out the years. And where are you going to want the years to go, on the top or the bottom? If I put years on top, I'm going to get years squared. But if I put years on the bottom and the days on top, guess what I can do with years? I can get a marker that works, maybe. You can cancel them out. So now, if I just stopped here and you just multiplied across, multiplied on bottom and divided, your answer would be in days. Okay, because that's the unit that you have. But we don't want days, we want seconds. So let's keep going on. The next one we're going to use should have days in it. Okay, so 1 day equals 24 hours. So 1 day on the bottom, 24 hours up top, and then just cancel out your days. Let's use the conversion that has hours in it. Let's put 1 hour on the bottom, 60 minutes up top. I put my hour on the bottom so that these 2 hours can cancel out. 1 minute on the bottom, 60 seconds on top, so that my minutes cancel out. And guess what the only unit that you're left with should be on the numerator, and it should be match exactly what you're looking for is. If it doesn't match what you're looking for is, then you need to have more conversions. So let's do step 5 and 6. Let's multiply and divide. Okay, so you get this insanely long, obnoxious number, 3.6 times 10 to the, and that is a much nicer number to look on your page. So I just put it into scientific notation and rounded to 3/6. Okay, so in this problem, it gives us the density of lead in grams per milliliter. That's our given. They're asking us to convert it into kilograms per liter. That's our looking for. Because we're having to do conversions between grams and kilograms, and we're trying to do a conversion between milliliters and liters. So let's first look at the conversion between grams and kilograms. On your note, you should see 1,000 grams equals 1 kilogram. Now we could need a conversion between milliliters and liters, and it's actually very similar. 1,000 milliliters equals 1 liter. Okay, so I have 2 conversions, so now let's set up my T-chart. My given goes here. Now, be careful with the units. You're going to be tempted to want to put grams per milliliter up top, but remember, that's a dividing line right there. So really it's grams milliliter. I always start with the unit on the top. So just for right now, pretend like milliliters doesn't exist. Just don't even look at it. Don't look at it. I know you're looking at it. Don't look at it. Look at the grams. Let's convert from grams to something else. Oh, I forgot to do my boxes. How many conversions do I have? 2. So I need to have 2 boxes. Alright, so in the first box, I'm going to just focus on the grams. If I want to go from grams to kilograms, I'm going to use this guy. Okay, now I need to make sure that my milliliters is changed into liters. So I can take my second guy and put him here, 1,000 milliliters on top, 1 liter on bottom. And you might be like, wait, what's happening? The milliliters is on top here and it's on bottom here, so I can still cancel them out. Even if they're not next to each other, as long as one's on top and one's on bottom, you can cancel them out. So guess what 2 units we're left with? Kilograms per liter. See that? So now I just multiply all the way across, which is 11.34. Multiply all the way on the bottom, so I get 11.34 kilograms divided by 1,000 liters. So this is your actual number, and then it has kilograms per liter. Okay, so this one's a little bit different because it's a 2-step problem. We have chromium and we have iron, and they want to know the total mass, so what they're really wanting us to do is add them together. Okay? And they want the mass in kilograms. So this guy right here is already in kilograms, so he's good to go. The only thing we need to do is first we have to convert grams to kilograms, then we can add them together. So kilograms is what we're looking for. I only have 1 conversion factor, so there's 1 box. 1,000 grams goes on the bottom. 1 kilogram goes up top. My grams cancel out. I multiply across. Multiply on the bottom. And then I just divide, and so you get 3.25 kilograms. Most of y'all, you'll go through this whole thing and you'll be like, oh my gosh, I'm so tired, I'm so exhausted. Here's my answer, let me circle it. Wait! It's not your answer, because what is it really asking you to do? Add them. So here's my chromium, I add it to my iron, and this is my mass, so that's my total. Alright, so what it's asking us to do, basically, is here's your bottle, it has 1.8 liters in it. We want it to be 2 liters. So basically it's saying how much do we have to fill it up. Well, let's just do the simple. That's how much liters you still need. That was the first step, though. The second step was they don't want to know this in liters. They want to know it in milliliters. So what I'm going to have you try to do on your own is I want you to go ahead and try and convert this liters into milliliters on your own. Have a great day. How do I stop it? Oh.